All right, so here we go. Got four graphs to go through. It says solve, and pretty simply by graphing, solve by graphing. Um, so let's graph them. This first one of 4 minus 2x is greater than y. I'm going to change that to y is less than negative 2x plus 4. And I think probably from there you'll be comfortable with graphing that. It's a linear equation, so we got 1, 2, 3, 4. Slope of negative 2. So we're going to go ahead and get these other points in here just to help me graph it. And we're looking for the line that's going through that will be a dotted line. This is not or equal to. These are not solutions right on that line. And then where y is less than. So where y is less than. All right, there's the first one. Next we've got y is less than or greater than or equal to negative 2x cubed plus 8. And so this is probably going to be easiest to graph by factoring. So just because it's inequality, think back to when we graphed these cubic functions earlier. You're just going to find your roots and head on through. So y is greater than or equal to, and I factor out a negative 2x. So negative 2x times, so that leaves me with x squared minus 4, and hey, that's a difference of squares, and so I end up with y is greater than or equal to negative 2x with x plus 2 and x minus 2. And so now I know my roots. My roots are going to be at 0, negative 2, and 2. And go ahead and throw those on my graph here. At 0, 2, and negative 2. All right, and it's my leading coefficient's a negative 2, and it's a odd degree, and so it's going to start at positive infinity, but end at negative infinity. So just a rough sketch is fine here. Head down below, got a curve, come back up, and now I'm making a solid line because it's or equal to. So below, up, it's got to turn again, come back down. Looks something like that, the line itself. Now I'm looking for where y is greater than, and so I'm just going to shade up above. All right, and so really nothing new, just all we're adding is shading. Okay, here we go. We've got the absolute value of x is less than or equal to 2. So let's go ahead and head on through this one. So if I have the absolute value of x is less than or equal to 2, if x is positive, then x is less than or equal to 2. I can graph that line. So head on over to 2. It's going to be a solid line. And looking for where x is less than. So it's going to shade over here. Now this looks like it's going to be an or situation, so I'm not going to shade too far. And over here we got a minus. If x is a negative, then that means that x is greater than or equal to negative 2. And so over here to negative 2. And solid line. All right. And these numbers here are going to be my solutions to my first equation, but I've got two of them here, so I need to find out where y is greater than x, and that means I'm going to start, it's going to be a dotted line right through slope of 1 and a y-intercept of 0, and I'm looking for where y is greater than, so it's greater than over here, and my solution set then is where they are both true. So let's go with solid line here, solid line here, dotted, and then shade in between. Those are where both of the inequalities are true. And again, dotted line here at the bottom. Dotted. All right. Lastly, a real big one. We got three pieces here, but we'll just go through the process the exact same way. So where is x greater than 1? Well, I'm going to come on over to where x is, it's going to be a dotted line at x equals 1, and I'm looking for numbers that are greater, so shading over here. Next, I've got y plus 1. The absolute value of y plus 1 is less than or equal to 3. So if y plus 1 is positive, if it's positive, then y plus 1 is less than or equal to 3. And so that's going to be y is less than or equal to 2. And so come on over. Actually, we'll do both these first. If it's negative, then y plus 1 is greater than or equal to negative 3. And so that value is staying the same, and we're setting it the opposite here and opposite here. So switching that inequality and setting equal to negative 3. Subtract the 1, so this time we've got y is greater than or equal to negative 4. And so let's see what's going on here. We'll do this one in red. We had the last, the first graph was in blue. This one we'll do in red. And so where y is greater than or equal to negative 4, so solid line here, and where y values are greater than, but the boundary for this one's going to end when y is less than 2, so solid line at 2 as well, and less than. So far, this region right here, actually I'll do it dark for just a second. Right now, this region in here is our solution set, but that last inequality is going to help us define that a little bit more tightly. So we've got 3y minus 2x is greater than or equal to negative 6. And I'm going to just I was going to set it equal to y equal into slope-intercept form, but it's set up nicely right now for just graphing its roots. And so if y is 0, x would have to be 3. And so I know it's got an intercept at 3, 0. And if x was 0, then y would have to be negative 2. And so it's got a point here at 0, negative 2. And go ahead and graph it. And it's going to be where y is greater than, so it's up above. But here's our line. It's a solid line because it's or equal to. And so our solution is going to be, and I'll do it kind of in a dark orange here, dotted line here, dotted line right here, solid line, and here's our solution area. And again, this part right here is dotted. All right, hope that helped.